All right, MAP4C, day 51, first day of the new unit on algebraic models is what this chapter is called. Just like most of the units, we're going to have a couple of short lessons. Some of it will be review, and then some of it new stuff that will get us going on this new unit. So today is a 2 lesson day. They'll be short though, we hope. The goal today: use formulas drawn from real life applications, including those that use square roots. So this first half of the day is all about roots. Give 5 numbers that are easy to take the square root of, and anything that is something squared. 4 is 2 squared. These are all numbers that are easy to take the square root of. 1 is one you might forget about. The square root of 1 is 1, and lots of them. Lots and lots of them. Get one formula that when we use it, we need to find a square root. The one that always comes immediately to mind to me is the Pythagorean theorem, right? Oops, darn, that should say c squared. And however you remember the Pythagorean theorem, whether it's c squared first or whatever. But whenever we're finding one of these, we sub in for one of them, and we take the square root at the end. Another one is the cosine law. Remember way back in trig, and you probably come up with a few more. Whatever you put in there is probably fine. Is it possible to take the square root of a negative? So the idea of square root of a negative number. Well, you try it on your calculator, you can't do it. It's not possible. And the whole idea is the start of the lesson today. So we're on to the first lesson here. Square roots and formulas. There's a couple of pages there. Use formulas drawn from real life applications and including those that use square roots. Since 6 times 6 is 36, then the opposite way, the square root of 36 is 6. Right? We can think of it the opposite way. Notice also, negative 6 times negative 6 is 36. So negative 6 is also a square root of 36. And the notation is we have a negative square root. The square root of 36 always implies a positive number, right? And so negative of that implies the negative square root. Good, good, good. Evaluate, it says, estimate, then calculate and round if you can't be exact. So some of these we've got to know, like what's the square root of 144? It's 12. That's it, right? Because that's 12 times 12. Negative square root of 49, well, that part's 7, right? So this part's 7, it's just negative 7 is the negative square root of 49. This one we don't know, right? This one we don't know, so it says estimate first. So I'm going to estimate over here. Well, what are some perfect squares that are close to that? Well, the square root of 64 would be 8. The square root of 81 would be 9. And so I know this answer is going to be somewhere between 8 and 9, and it's going to be closer to 8, isn't it? So my estimate might be 8.1 or 8.2. And then you fire that into a calculator. Let me see if I can find my calculator. Is it open? It's not open. I'll have to find my calculator. Is my calculator on my list? No. Oops. Open my calculator. Accessories, calculator, there we go. And then in this one you can't type it like it appears. In most calculators you'd hit your root button, and then hit 64 and then enter. But I have to go not 68, 68, and then I hit my root button. So it's 8.246 about 8.246, and we were pretty close on our estimate. This one, 5 root 12. Well, root 12, and again, we think of this in our head. You wouldn't necessarily write this down. Think of it in your head. The root of 9 is 3. The root of 16 is 4, and so the root of 12 is going to be in between here. So the root of 12 might be about 3.5. Well, what's 5 times 3.5? Well, 5 times 3 is 15, and then half of 5 is 2.5. So I might estimate this as about 17.5, and now I'm going to put that into my calculator again. 5 times 12 root, well, let me go again, clear, clear, clear. 5 times 12, hit my square root button, and then press equals, and I got about 17.3. That's approximate, right? And again, on other calculators, you might be able to put it straight in. This might be, you know, the square root might be above your squared button maybe, so you have to press second function in there. That's a time sign there, and then 12, and let's press equals. However, you know, use your calculator to get that. You should write that in your notes so you've got it for later. This is actually the Pythagorean theorem, isn't it? But I'm solving for one of the other sides. It's saying with h is 10 and b is 8, what's a? Well, I'm just going to substitute in here, right? I got h is 10, b is 8, and then I got to do this stuff inside the roots before I take the square root. That's 100. Do as much of this as you can in your head. Can you subtract 64 from 100 in your head? I hope so. If not, calculator. Square root of 36 is 6. And that goes evenly. I don't need my calculator. All right, this is a really fancy formula called Heron's formula. Heron's formula gives the area of a triangle with sides A, B, and C. In this case, we've got a sail. This sail is triple ply. The material costs $55 a square meter. How much does it cost? Well, notice that this formula is actually 2 steps. This S in here is this formula right there. So before we get going, we actually have to calculate what S is. A is, well, it doesn't matter the order, I guess, 1.2. B was 1.6 and C was 2.4. I put all those into this little formula, 1.6 and 2.4. Remember, you either press equals there before you divide by 2 or put that in brackets, one or the other. And then I get 2.6 there. So the S value then is 2.6. And so in my Heron's formula, long root there, notice this formula, and the formulas we're going to be dealing with this whole chapter, you don't have to memorize, okay? I'll give them to you, and then you'll mess around with them. So A was 1.2, B was 1.6, C was 2.4, and then S was 2.6 because we just calculated that, right? And then now we can put into Heron's formula and find the area of that sail. S was 2.6. Now, we don't really care where this formula came from or anything like that. S was 2.6, B was 1.6, and S was 2.6. So you could put that all into your calculator in one step, and some people that have the root button, that you can hit the root button and then use brackets and all that stuff, you might do that. I'm going to clean it up first. I make lots of mistakes on my calculator, so I'm going to clean this up before I start putting it in my calculator. I'm actually going to do some of these brackets because this is easy to do in my head. 2.6 subtract 1.2 is 1.4. That's 1.0. This is 0.2. And that expression's way easier to put into your calculator. That's just multiply, right? And then I put that into my calculator, square root at the end. I get about 0.853 meters squared. This is per ply, right? So each sail is going to take up that much material, but it says I want triple ply. So triple ply, I'm going to take 0.853 and multiply by 3. I do that in my calculator. 0.853 times, clear, 0.8553 times 3, and that's 2.559 meters squared in total. So then what's the cost? Well, they said the cost was $55 a square meter, right? So just multiply that answer by 55. I get $140 for that sale. That's without labor and all that other business. sewing, 75 cents. I think that's it for it for part one. Part two of today's lessons coming up again soon, so you should probably watch that video before you get to any of the homework. Get the 2 videos out of the way, um, and then all the homework, the double homework in class. And I think it might be double FAQ too, today. So lots of work.